Hello everyone, welcome to the session on energy engineering. I am Satish H, Assistant Professor, Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. So this session we will discuss about the photovoltaic, okay, or solar photovoltaic systems, okay. So during the introduction classes and then the classes which are successive to the introduction classes, you have learned that the solar energy can be harnessed using two systems basically. One is thermal systems and as well as photovoltaic systems. So you have seen how the solar power can be converted to the useful form of energy using the thermal systems with the help of the different thermal systems that you have studied in the previous sessions. So these sessions we will see the one of the solar energy conversion systems, that is photovoltaic systems, okay. So here the solar energy is directly converted into the electric energy, okay. In the case of a solar photovoltaic systems, the solar energy can be directly converted into the electrical energy. Some of the examples are the applications where this photovoltaic cells used to convert into the useful form of energy, that is electrical energy. Might be you might have seen the street lights, okay. I was also explaining during the introduction classes where you have a solar panel or the solar cell at the top of this you have a solar panel, okay, that will trap the radiation which is coming from the sun, that is stored using the battery, and then the energy which is stored inside the battery during the daytime, so that can be used to light up the lamp, that is a street lamp, okay. So that is one of the example of a solar photovoltaic system. Likewise we also discussed about the example of satellites, where the satellites for their movement or for orbiting around the planets, so they make use of the energy that is coming from the sun, so that is using a photovoltaic cells, okay. So there you have one more applications, okay. Likewise you can convert the energy available from the sun, that is in the form of radiations, or the energy which is stored in the light, that is energy in the form of photons, can be directly converted into the electrical energy, okay. That is one of the definition of solar photovoltaic systems, okay. So we need one conversion device in order to convert this energy which is stored in the form of radiations into the electrical energy. That device we call that as a solar photovoltaic cell, or in short it is also called as a solar cell, okay. So it is basically a device which is helps to convert solar power or the solar energy into the electrical energy. So we have electrical current source, okay, driven by the flux of radiations, okay. So when this energy coming from the sun or in the form of a radiation or the light, so when it falls on this photovoltaic cell or the solar cell, okay, so electric current will be produced, okay, that can be used for various applications, okay. So some of the examples are space satellites, as I explained before, that make use of photovoltaic cells in order to convert the energy from the sun into the useful form of energy, that is electrical energy. And then we have one of the most disadvantages, okay, since the solar energy is available abundantly, what makes us not using that solar energy is because of one of the disadvantage, that is it is expensive, okay. So among the solar photovoltaic systems, that solar cell is an expensive component, okay. So economy wise, okay, if you think, the other sources of energy becomes cheaper, okay, compared to this one, okay. So that is one of the drawback, okay, or the or the disadvantages of using a solar photovoltaic systems, okay. So this is solar cells is the expensive component. And then the efficiency of this whole system, solar photovoltaic system, is very less. Okay, so it is of the order of about 10 to 20%. Okay, which is very, very less. Okay, so that is one more disadvantage. Okay, so and then solar energy density. Okay, so about 1 to 2 kilowatt hour, okay, is produced per square meter. Okay, if we have a solar panel of measuring the length and breadth 1 meter each. Okay, if you have that area of 1 square meter area, and then if you collect the radiation, and then if you the energy produced from that is 1 to 2 kilowatt hour, which is comparatively less. Okay, and then about if you have a panel or a size of the solar cell of about 10 centimeter by 10 centimeters. Okay, so it can have a current of 2 amperes. Okay, that is to give you an idea, okay, how much energy is produced, okay, from that solar radiations. Okay, so and then one of the advantages of this solar radiation is, okay, so it has a very a good lifespan. Okay, it is having about 20 years of lifespan. Okay, if you install it once, so it continuously works, and then it will last for about 20 years. That is one of the important advantage of a solar photovoltaic cells. Okay, so systems. So and then later on we will discuss about some of the advantages. Okay, so the first advantage is, okay, here, as I said before while explaining, while introducing the photovoltaic systems, okay, so the solar energy is directly converted into the electrical energy. Okay, so what does that mean is, okay, so no thermomechanical linkages involved. Okay, it is very direct. Okay, nothing is involved in between. Okay, there is no moving parts, like in order to convert one form of energy to the other form of energy. Okay, normally if you take an IC engine for example, okay, where the energy which is stored in the fuel is converted into the mechanical energy or the rotation of the shaft, there in order to convert that one form of energy, that is chemical energy, into the mechanical energy, there are a lot of mechanical linkages are involved. Okay, the efficiency of the system, whole system, will be lost during the transmission as well. Okay, so one of the advantage of this photovoltaic systems is there are no mechanical linkages or the moving parts that are involved. Okay, so it is reliable. Okay, you can rely on that system. Okay, it works fine. Okay, without any failure in the most of the cases. And then it is modular. You can make it in a compact modules. Okay, so and then it is durable, and it is a maintenance free. Okay, since there are no mechanical parts or the moving parts are involved, or no thermo-mechanical linkages are involved, you have a maintenance free systems. Okay, for photovoltaic systems. Okay, so and then they are quieter in operation, of course, because it is just a panel, and then the radiation falls on it, and then it directly converts to the electrical energy, so there doesn't make any noise. Okay, like any other systems of conversion. Okay, so as I giving an example of IC engine, there is also a conversion of one form of energy to the other form of energy is taking place. Because of involvement of a lot of moving components, there might be a lot of noise involved there. Okay, whereas in this case it is very quiet, there is no noise involved, and then it is compatible. Okay, and then instantaneous response. Okay, immediately as soon as this the radiation from the sun, the light energy falls onto these solar photovoltaic systems. Okay, immediate response will be there, that is immediate conversion of that into the electrical energy. And then higher lifespans, as I said, it is about 20 years, it is a lifespan of this photovoltaic system. And then no distribution network is necessary. Okay, because it can be installed where the energy is necessary. Like, okay, for example, street light example. Okay, you can install a panel at the top of it. Okay, top of the street light pole. Okay, so that is the utilization area itself. Okay, so there are no distribution area, because you can install it where we need energy, or where we need electrical energy. Okay, so right away we can install it at that spot itself. Okay, so there is no distribution of like energy is needed, or the network is needed. Okay, those are the some of the advantages. Okay, before going to the applications, we will discuss some of the disadvantages. Okay, of course it has certain disadvantages that makes us to, even though it is like a solar energy is abundantly available, and then it is a renewable type of energy. Okay, but it has certain disadvantages that makes or limits us to use it more and more. Okay, so one is definitely high cost. Okay, that solar cells is an expensive thing. Okay, so are the component. That is why the cost is one of the major disadvantage of a photovoltaic system. And then, as I said before, only 10 to 20% or 10 to 20% of efficiency. Okay, so that is one more. The second disadvantage, it has a low efficiency, and then solar energy density also less. Okay, so and then solar power is intermittent. Okay, so electrical energy storage is necessary, and it is also expensive. That means, what do you mean by solar power is intermittent? It is not available throughout whole day, that is 24 hours it is not available. Okay, during the daytime it is available. So suppose if the days are cloudy, definitely that intensity of the solar energy is very less. Okay, so it is not available continuously, so you need some kind of a storage devices. Okay, example battery, in order to store when the energy is available, and then make use the energy which is stored inside the battery when the demand is needed. Okay, so when this storage systems comes into the picture, so again solar cell itself is a costly or expensive, that is we discussed, like it is one of the disadvantages. If the storage systems also comes into the picture, it becomes more expensive thing. Okay, so that is why it is a disadvantage. That means solar power is intermittent. We need like a storage systems in order to use it for throughout the day. Okay, for example, and then we will see some of the examples. Okay, so one is space satellites. Okay, so you might have seen the satellites, they have on the both the sides arms. Okay, on the both of these arms the panels are arranged. Okay, so that is continuously exposed to the sun, and then the energy is absorbed. That will energy is utilized in order to do the like various operations of the satellites, for example revolving or orbiting about the planet. And then remote radio communication systems, here also we use the solar energy. And then marine warning lights. Okay, so these warning lights can operate, okay, with the help of solar energy as well. Lighting, as I said, street light applications. Okay, so and then we have water pumping. Okay, so solar energy converted into the electrical energy. That electrical energy can drive the pump in order to lift the water. Okay, and then medical refrigeration. Okay, so refrigerators also needs electrical energy. We can use this solar photovoltaic systems in order to produce that electricity that is needed for the keeping the substances or medical refrigeration running. Okay, so and then solar powered vehicles. Nowadays we are talking about since fossil fuels. Okay, so there are many problems associated with fossil fuels. For example, diesel or petrol. Okay, they liberate harmful gases into the atmosphere, and then considering the pollution. Okay, we are looking for alternative sources of energy in order to drive our vehicles. So the solar powered vehicles have a large potential in that area. A lot of research has been going on into the solar powered vehicles, battery technology, etc. So that could be a future. Okay, solar powered vehicles could be a future. Okay, the only disadvantage is the amount or the cost or expensive thing. Okay, so these are the some of the basically the introduction to what is solar photovoltaic systems as well as what are its advantages and disadvantages and applications. Okay, so what you have to remember is it converts the solar energy directly into the electrical energy. Okay, so next we will discuss about the other concepts, that is solar cell fundamentals, and then we will discuss about solar photovoltaic model. What do you mean by the solar photovoltaic, like a panel, and then solar photovoltaic array, and then we will also discuss about the classification of the solar cells. Okay, so as I explaining before, the solar photovoltaic systems are the uses a device or the instrument, okay, we can call it as, okay, so it is called as a solar cells or photovoltaic cells. Okay, so we will discuss that photovoltaic cell will convert the energy in the form of radiations or the light energy into the electrical energy directly. Okay, so let us try to understand what is that solar photovoltaic cell. Okay, our solar cell is made up of. Okay, so how does that function? Okay, so here we have a sketch of solar cell, okay, or the solar photovoltaic cell. Basically it is a semiconductor device. Okay, so in the semiconductor device we have a p-type silicon and the n-type silicon. We have a junction in between them. Okay, so by connecting a load across this p-type and n-type, when this changes will happen. Okay, so when the light energy or the energy from the sun in the form of a radiation or in the form of a photons falls on this like a semiconductor devices. Okay, so that the electrons try to escape, okay, across this junction, that will create kind of a like a current. Okay, so when the load is connected across them, that will produce the electricity. Okay, so the sketch shows a solar cell. Okay, so which is basically a semiconductor device. So it consists of, it is a p-type silicon at the bottom, okay, which has a greater thickness, and then the shaded part with a yellow color, that is n-type silicon. Okay, so between that we have a junction. Since it is p and n type of silicons on the both sides, we will have a p-n junction. Okay, in between them. Okay, so we have a metal electrode on the front side. This is the metal electrode on the front side, and then the radiation from the sun or the energy from the sun in the form of radiations or the photons or the light energy falls on this metal electrode on the front side. Okay, we have similarly metal electrode on the back side, and then these two metal electrodes are connected with the help of an external load. Okay, for example, if we have an external load, nothing but that is a utilization of the energy. If you connect that a light bulb, it needs certain amount of electrical load. Okay, so that is represented as a external load here. Okay, so basically what we have here, we have metal electrode on the front side and then metal electrode on the back side. We have n-type silicon and then p-type silicon, and then between we have a junction there, and then they are connected with the help of a external load. Okay, so when the radiation falls on this like a semiconductor device, okay, the electrons movement happen, okay, in between the junction, that is a p-n junction. Okay, so if you connect that the like a n and then p type, okay, the electrons from n type tries to come to the p type, or electrons from the n type of silicon, okay, try to escape to the p type of silicon. Okay, so this passage of electrons or the movement of electrons across this line here. Okay, so across this line, okay, when it is coming through the external load, okay, if you connect the bulb for example, okay, it will glow, okay, because of the movement of electrons are there. Okay, so this is about the solar cell. Okay, so the energy which is coming from the sun is converted into the okay, electrical energy using a device which is called as a semiconductor device. Okay, so basically p type has excess electrons and n type has a less number of electrons. Okay, so that is about solar cell fundamentals. Okay, basically it is a semiconductor device. It converts the energy from the sun into the electrical energy. So next we have solar photovoltaic module. Why do you need a module? Okay, so a solar photovoltaic cell is a basic component or the fundamental component, okay, or the basic element or the fundamental element. Okay, a single cell, okay, if you take this single cell, okay, it cannot it has a very small output, okay, if you have that. Okay, so and then it doesn't protect against this dust, okay, or the moisture. Okay, so that is one of the one more disadvantage of it. Okay, so if you the idea is to interconnect like a number of appropriate number of solar cells, okay, in order to form, okay, in order to get this workable voltage and then the power. Okay, in order to have a more power, workable voltage and more power, we need to interconnect these solar cells together. Okay, so that the interconnected solar cells together is called as a photovoltaic module. Okay, so if you look at this sketch here, this is one single cell. Okay, this is a single cell, it is here. Okay, so and then when you have number of photovoltaic cells are interconnected together in order to produce a workable voltage and more power, then we call it as a photovoltaic module here. Okay, the commercially used the photovoltaic modules normally has this 32 to 36 number of cells. Okay, so which is of silicon, which can produce up to like 12 volts. Okay, that is commercially used. Okay, the solar photovoltaic module we have. Okay, so what you basically do is we interconnect the solar cells. So because individual cell can produce very less power, so by interconnecting them we can have a workable voltage as well as a workable power. Okay, so that is called as about the module. And then we have one more thing, that is a solar PV panel. Okay, so according to the definition, several solar modules are connected in series or parallel to increase the voltage and current. Okay, the basic idea here is we need to get a more voltage, more current. Okay, so for the various applications, what you do is we interconnect the modules itself. Okay, so here in the module we interconnected the cells, whereas in the case of the panel we interconnecting the modules itself. Okay, so this itself, okay, represents the module. Okay, this is one more module. Like that we have like a 6 modules here. Okay, so here the smallest component is solar cell, which are interconnected to like in order to make a module, and then the modules are interconnected, okay, in series or parallel in order to make a solar panel. Okay, so this is about the solar panel. Okay, definition is several solar modules are interconnected in series or parallel to increase the voltage or current. Okay, so that is called as a solar panels. Okay, we don't stop it there, we will go further. Okay, so if you need more voltage and current, what do? You interconnect, okay, number of solar panels. Okay, so that is called as a solar array. Okay, so it is so according to the large number of interconnected solar panels, so you have a large number of such a panels are interconnected, then you will get a more voltage and more current. Okay, then that setup is called as a solar photovoltaic array. Okay, so it is stationary, it can be stationary, or it is solar tracking mechanism. Okay, as the sun moves, okay, from east to west, okay, you can have a mechanism that will track the sun movement. Okay, so that will you have a setup like both stationary as well as movable kind of things. Okay, so this is about a fundamentals of a solar cell, and then we have a module, and then we have a solar panel, and then solar photovoltaic array. Okay, the smallest component is solar cell. When you interconnect them together, you will get this solar module. When you interconnect solar modules, you will get the solar panel. When you interconnect large number of solar panels together, you will get the solar photovoltaic array. Okay, the idea is to get the more voltage and more current. Okay, how do you do that? You interconnect them with appropriate number, okay, in series or parallel. You will get the more voltage and then the more current. Okay, that is a basic idea behind this module as well as panel and as well as array. Okay, so we have the classification of the solar cells. Okay, the solar cells can be classified based on the thickness of the like a active material that is used. Okay, so one is bulk material cell, and then one more is thin film cell. Okay, these are the classification of the solar cells based on the thickness of the active material that is being used. Okay, so and then one more classification is based on the junction structure. You have PN homo junction cell, that is one of the classification, PN heterojunction cell, and then metal semiconductor, and then PN multi-junction cell. Okay, so we know that the semiconductor is made up of a p-type and n-type material. They have a kind of junction in between them. So based on that, okay, you can classify this as solar cells. Okay, so that is about solar cell fundamentals, and then a module, and then solar panel, solar array, and then a brief a classification of how you classify this solar cells. So let us discuss about the last topic for this session, that is based on the numericals. So in order to solve the numericals which are related to this solar power energy, so basically the numericals are based on the local apparent time, or it is called as a solar time. The equation that we are going to use in order to find out local apparent time or the solar time is as given here. So this is the solar time is equal to standard time plus or minus, okay, so plus 4 into L standard minus of L LOC plus E. Okay, so here ST stand for standard and then LOC for the location. Okay, so here LST, what does mean L standard? Okay, it is a standard longitude used for measuring standard time of the country. I repeat that. So L suffix st, it stands for standard longitude used for the measuring the standard time of the country, and then L location, that is LOC, the longitude of the observer's location, where the observer is. Okay, that location is given by, so LOC. So here we have plus or minus. Okay, when to use plus, when to use the minus. Okay, the plus sign is used, okay, if the standard meridian of the country lies in the western hemisphere. Okay, so we have eastern hemisphere and western hemisphere. If that country, okay, where that what is given in the problem, if it lies in the western hemisphere, then the positive sign is going to be used, and then the negative sign is used if the standard meridian of the country lies in the eastern hemisphere. Okay, the negative sign when you are going to use is, okay, when the standard meridian of the country lies in the eastern hemisphere. Okay, for example, if you take India, it is a eastern country we call. Okay, so then you have to take the negative sign. Okay, and then capital letter E, okay, that is at plus E. Okay, it stands for correction. Okay, that would be given in the problem. Okay, so the problem will be something like, okay, calculate the solar time, and then standard, all these parameters are given. For example, standard time is given, and then standard longitude, okay, that is also might have given. Okay, and then L location, the longitude of the observer location, where the observer is. Okay, that the coordinates will also be given, and then correction factor will be given, and the country name will be given. Okay, so based on that you can select this positive and negative sign. Okay, so this is a simple formula that you can use, okay, in order to find out this solar time or the local apparent time. So let us discuss one problem which is based on this formula. Okay, so the problem reads something like this: calculate the local apparent time, in short we can also call it as LAT, corresponding to 1430 hours. Okay, so corresponding to 1430 hours, okay. So 14 is hours and 30 is the minutes, okay. So it is off past 14 hours, okay. At Mumbai, the location is given, okay. So and then coordinates for that location is also given. So here 19 degrees 7 minutes north and then 75 degrees 51 minutes east, okay. How to read this? This is degree, we all understand that. And then if you have, okay, number to the power of a hyphen will be there, so then it is read as a minutes, okay. And then N stands for north and then here E stands for east, okay. This is 75 degrees and then 51 minutes east, okay. And the date is also given, on which day? It is July 4th, okay. So the location is given and then standard time is also given and then the coordinates for that location is also given. So in India, the standard time is based on, okay, this is a standard, okay, is based on 82.5 degrees east, okay. This is the Indian standard time, okay, is based on 82.5 degrees east, okay. And the equation of the time correction is, okay, as I was explaining while explaining the formula, so capital E stands for the correction factor, that is minus 3.5. This is minutes, okay. So hyphen, as I said, okay, so it is minutes for the given location, okay. So this is a problem they have given us. The formula we are going to use for this is, so solar time is equal to standard time plus or minus 4 into L standard minus of L of location, that is longitude of location, plus error, that is capital E, okay. That is a formula we are going to make use in order to calculate the solar time, okay. So let us discuss one by one, okay, what are all given in the problem, okay. So this is the standard time, so which is also given, so this is 14 hours 30 minutes, okay, or 1430 hours, that is Indian standard time is given, okay. So and then, as I said, if this country falls in western hemisphere, then we have to take in this formula as positive. If the country lies in eastern hemisphere, okay, so then we have to take it as a negative. Since we are discussing about Mumbai, so India, so that is in the eastern hemisphere, so negative sign should be taken, okay. So that note has been written here. So because India falls in eastern hemisphere, okay, so because India falls in eastern hemisphere, negative sign we will take, okay. So and then standard longitude, okay, that is in degrees, okay. So standard longitude, okay, this is given here, okay. So for Indian standard time, the longitude is 82.5 degree east, okay. So that is we are taken here, okay. So and then longitude of location, that is in also degrees, okay. So the Mumbai is the location they have given us, okay. What is the longitude? It is 75 degrees 51 minutes, okay. Here see 75 degrees and 51 minutes, okay. Here the problem is everything we are substituting in degrees, okay. So here see in the brackets we have mentioned it as a degrees. This is all right because it is already in degrees, okay. So how to convert this minutes, okay, into degrees here, okay. So to convert a minute to the degrees, okay, 75 degrees plus 51 minutes, okay. So that is 51 divided by 60 if you do, okay, that will be, the minutes will be converted into the, okay, degrees, okay. If you do that and then if we add them both together, so you will get this the longitude of location, which is equal to 75.85 degrees, okay. So that is the value you are going to get. So we have got all these details which we need in order to solve this problem, okay. So standard time we know that, okay, that is 14 hours 30 minutes or 1430 hours, and this sign will be negative, and then the standard longitude is 82.5 degrees and longitude of location is 75.85 degrees, okay. And of course we know the correction that is given in problem, that is minus 3.5 degrees, okay. I'm sorry, it is in minutes, okay, minus 3.5 minutes. So let us substitute and then solve this, okay, and then simplify this, okay. So for substitution, the solar time or LAT is equal to what we have, the standard time, which is equal to 14 hours 30 minutes. Okay, so minus because India falls in eastern hemisphere. Okay, 4 into longitude, standard longitude. Okay, so here it is equal to 82.5 degrees. Okay, we have substituted that. Okay, so and then longitude of location. What is the longitude of location? Here 75.85 degrees. Okay, so we are also substituted this value here, and then of course the correction factor plus of minus 3.5. Okay, that is given in the problem. So plus of minus 3.5 minutes. Okay, careful about that. So we are also substituted that. Okay, so let us simplify further. This is 14 hours 30 minutes minus of 4 into 82.5 degrees minus of 75.85 degrees. Okay, it will comes up to 4 times 6.65, right? So this is in degrees itself. Okay, minus of 3.5 minutes we have. Okay, so if you see further simplify this, okay, this 14 hours 30 minutes we kept it as it is, minus of, if you multiply these two, you will get it as 26.6 minutes. Okay, so and then minus 3.5 minutes we kept it as it is. Okay, this is coming from multiplication of these two numbers. Okay, so now keeping separate the hours. Okay, so what we have is, okay, here we have this 30 minutes. Okay, minus of, okay, so this is 26.6 minutes minus of 3.5 minutes. Okay, so here 26.6 minus of 3.5. Okay, you will get somewhere around, okay, 29, 30.1 minute. Okay, so if you add them, these two numbers together, you will get in terms of minutes, okay, that is 30.1 minutes. But here we have 30 minutes. Okay, so 30 minus of 30.1 minutes. Okay, I repeat, 30 minus of 30.1 minute, you will get it as minus 0.1 minute. Okay, so this is nothing but you have to, from the 14 hours, you have to subtract 0.1 minute here. Okay, so if you do that, okay, so it will become 30 hours 59.9 minutes. Okay, so that is the answer you will get. Okay, so subtracting from the 14 hours, a 0.1 minute you are subtracting. Okay, so you will get 13 hours 59.9 minutes. Okay, this is the answer for solar time or LAT. Okay, so this is how, when the problem is given, okay, so you have to solve, okay, for a solar time, or it is also called as local apparent time. So other data will be given. Okay, you have to substitute that data, and then only you have to careful about is what are degrees and then the minutes. Okay, so and then you have to simplify something like this in order to get the answer. Okay, so this is about the various concepts we have discussed in this session. Okay, we started with photovoltaic the conversion systems or systems. In that we have discussed advantages, applications and disadvantages of photovoltaic systems. Later on we discussed about like a photovoltaic cell, and then combination of the cells you can make it as a module to, okay, panel to array. Okay, so that we have also discussed, and the lastly we have seen, okay, some of the numericals which are based on the solar time or local apparent time. So that's all for the session. Thank you so much.